Alright, so in this video, I'm going to be proving to you guys that 2 plus 2 is equal to 5. So, to do this proof, what I'm first going to do is start with a true statement, that 0 is equal to 0, which is obviously a true statement because any number is equal to itself. Now from here, what I'm going to do is rewrite 0 on my left-hand side as 20 minus 20, and rewrite the 0 on my right-hand side as 25 minus 25. So now I get 20 minus 20 is equal to 25 minus 25, which is again a true statement because 20 minus 20 is 0, and 25 minus 25 is also 0. Now from here, I'm going to rewrite 20 as 4 times 5. So now I get 4 times 5 minus 4 times 5 is equal to 25. I'm going to rewrite this as 5 times 5. So I get 4 times 5 minus 4 times 5 is equal to 5 times 5 minus 5 times 5. And now, if I have something in the form a times b minus a times b is equal to b times b minus b times b, which is this form, well, notice how we can simplify this by factoring out the greatest common factor. So for my left-hand side, we have a greatest common factor of either a or b because both of them are in both terms. So what I'm going to do is I'm going to rewrite this as a times b minus b. Basically, I factored out a. Now for my right-hand side, all we have is b because that's the only term for my right-hand side. So I'll just factor out b. So I get b times b minus b. So now in the case of this, for my left-hand side, I'm going to factor out 4. So I get 4 times 5 minus 5, which is equal to, for my right-hand side, I'm going to factor out 5. So I get 5 times 5 minus 5. So now I have 4 times 5 minus 5 is equal to 5 times 5 minus 5. And what we can do over here is, if I have something in the form a times b minus b is equal to b times b minus b, we'll notice how we can just cancel these two out, meaning that a is equal to b. So in this case, I have 4 times 5 minus 5 is equal to 5 times 5 minus 5. I can divide both sides by 5 minus 5. And these two cancel out, these two cancel out, and I am left with 4 is equal to 5. Now, going back to our original equation, I said that I was going to prove that 2 plus 2 is equal to 5, right? Well, what is 4 equal to? 4 is equal to 2 plus 2. So, I get 2 plus 2 is equal to 5. So I just proved that 2 plus 2 is equal to 5. And now I know what you're thinking. This is mathematically incorrect, right? How can 2 plus 2 equals 5 when 2 plus 2 is equal to 4? Well, look back here and try to figure out where I made an error. So, the error is actually right here in this step, where I divided both sides by 5 minus 5. So let me write this right here. I have 4 times 5 minus 5 is equal to 5 times 5 minus 5, right? Well, instead of just going on and dividing both sides by 5 minus 5, what is 5 minus 5? 5 minus 5 is equal to 0, right? So this is basically 4 times 0 is equal to 5 times 0. And then now, if I try to divide both sides by 0, well, 0 divided by 0, that is not equal to 1. 0 divided by 0, that's indeterminate. So we can't actually cancel these out, because if we cancel it out, we're implying that 0 divided by 0 is equal to 1, which is wrong. So that's actually where I made the mistake when I canceled out the 5 minus 5s. I wasn't allowed to do that because that's basically dividing 0 by 0, and that is against the laws of mathematics. So this means that 2 plus 2 is not equal to 5. So, yeah. Alright, so in this video, I'm going to be proving to you guys that pi is equal to 3. So as you guys probably already know, pi is an irrational number, meaning it doesn't have a whole number value, and it's actually equal to 3.14159, and on and so forth forever. So that's why it's an irrational number. It's the just don't stop going. So in this video, I'm going to be proving to you guys that pi is actually equal to 3 and not the irrational number that we all know it is. So what I'm first going to do is start with the statement x is equal to pi plus 3 over 2. So all I'm doing is I'm giving a value to a variable, which is completely legal. So now what I'm going to do is multiply both sides by 2. So I get 2 times x is equal to pi plus 3 over 2 times 2. Now, 2 times x is equal to 2x. So I get 2x is equal to, these two 2's cancel out, pi plus 3. So I get 2x is equal to pi plus 3. And now, from here, I'm going to multiply both sides by pi minus 3. So I have pi minus 3 times 2x is equal to pi plus 3 times pi minus 3. Now, pi plus 3 times pi minus 3, I'm going to distribute the pi, so I get pi squared plus 3 pi minus 3 pi, which they just simply cancel out, plus 3 pi minus 3 pi. These two cancel out. And then I have minus 9 at the end. So this is, I can just say this is pi squared minus 9. And for my left-hand side, I can distribute the 2x, so I get 2x pi minus 6x. And now from here, I'm going to add x squared on both sides. So I have x squared plus 2x pi minus 6x is equal to pi squared minus 9 plus x squared. And let me just reorder this real quick. I'm going to write this as x squared minus 6x plus 9. So I'm going to add 9 on both sides. Is equal to x squared minus 2 pi x. So I'm going to subtract 2 pi x on both sides. And at the end, plus pi squared. So I have x squared minus 6x plus 9 is equal to x squared minus 2 pi x plus pi squared. And now, x squared minus 6x plus 9, this factors out into x minus 3 squared. And x squared minus 2 pi x plus pi squared is the same thing as x minus pi squared. So I have x minus 3 squared is equal to x minus pi squared. And now, I want to cancel these two squares, so I'm going to take the square root on both sides. So now the square root of x minus 3 squared is equal to x minus 3. And the square root of x minus pi squared is equal to x minus pi. So I get x minus 3 is equal to x minus pi. So now I'm going to cancel these two x's out by subtracting x on both sides. So now I get negative 3 is equal to negative pi. And now if I multiply both sides by negative 1, I get pi is equal to 3. So there you have it. I just proved that pi is equal to 3. So now where did I go wrong? Because obviously we know that pi is not equal to 3. So where did I go wrong? Well, I actually went wrong on this step right here, where I said that the square root of x minus 3 squared and the square root of x minus pi squared is equal to x minus 3 and x minus pi respectively. Well, this is actually not true. the square root of x minus 3 squared isn't equal to x minus 3, is equal to the absolute value of x minus 3. And same goes with the square root of x minus pi squared. It's not equal to x minus pi, it's equal to the absolute value of x minus pi. So the reason this is so important is because now I get x minus 3 is equal to negative x minus pi. Or also negative x minus 3 is equal to positive x minus pi, since we're taking the absolute value of these two. So if we want to solve x minus 3 is equal to negative x minus pi, we're going to have to first distribute the negative sign. So I get x minus 3 is equal to negative x plus pi. So now if I add x on both sides, these two cancel out. So I get 2x is equal to 3 plus pi. And x is equal to 3 plus pi over 2, which, going back, is what we started with. So there you have it. That is something really important to know, that the absolute value is, the square root of a square isn't just the normal version, it's the absolute value of that.